Alright, welcome to Graphing Rational Functions Level 2. Now, in our very first example, much like example 1, we first want to ask ourselves, hey, is this function top-heavy, balanced, or bottom-heavy? Notice we have all of our x's on the bottom, so it is definitely bottom-heavy. Okay, so when it's bottom-heavy, remember, that means that we have a horizontal asymptote at 0. Okay, so if you ever have a bottom-heavy function, there's no constant being added. We don't see anything being added or subtracted out here. Our horizontal asymptote will be at 0. Now let's talk about our vertical asymptote. Well, our vertical asymptote is going to be where whatever is in the denominator is equal to 0. And we can kind of cheat here. We can actually just look inside the square function and just set this x plus 4 equal to 0. Now, how are you going to get rid of a plus 4? Okay, so we'll subtract 4 from both sides. And this will, of course, give us x equals negative 4, which in turn is our vertical asymptote. Okay, now that we have the horizontal and vertical asymptote, we can go ahead and draw our x and y axis. And let's go ahead, and I'm going to switch over to a nice red color here. Let me draw my horizontal axis asymptote that goes through the horizontal axis right there. And it looks like our vertical asymptote is at negative 4. So 1, 2, 3, 4. We draw that vertical line. Remember, in asymptote, it's not actually on the graph. It's just a value that our graph approaches but can never cross. Alright, so switching back to white. Now when we graph this, the cool thing about this is that our portion of the function that should be in quadrant 1, because remember this is a positive function, it will essentially look the same as whenever we have x terms in the denominator. However, notice here we don't have just an x, we have an x squared ultimately. And so what's the rule of squaring things? Well, anytime you square something, it will always become a positive. If we have a positive squared, well, a positive times a positive is a positive. And if we have a negative squared, a negative times a negative is a negative. So the other portion of this graph will actually be in this quadrant 2, essentially, because none of the x values can ever be negative once they've been squared. So notice this will just be kind of the difference between having an x on the bottom versus x squared. And let's go ahead and talk about our domain. Okay, well, we know we're looking at all the values of x, and we see that as this graph goes infinitely to the left, it's going all the way to negative infinity, comma. And as we go to the right, the question is, what value is stopping us? And it turns out it's this x equals negative 4 value. So we say negative infinity to negative 4, union, because remember we have the right hand of the graph to deal with, and we pick back up on the other side of negative 4, comma, and of course it goes all the way to positive infinity, which you can see right there. Now let's go ahead and talk about the range. And the range here is actually going to be a little bit different. So I would ask you, what is the lowest value of this graph? And if you were to say, hey, it's negative infinity, like our previous examples, well, obviously that would be incorrect. There's nothing here that's going down towards negative infinity. So if I were to start right here and I were to go as low as I possibly could, well, we see that this graph is approaching 0, however, it can never touch it. So the lowest our range is 0, and the highest, well, of course, that is trending on up to infinity. I would encourage you to pause this video right now, finish taking down these notes, and then we can go ahead and move on to example 2. Okay, here we are in example 3. And in this problem, we want to graph y equals negative 6 over x minus 5 squared plus 3. Now, we see initially that we have a bottom-heavy function, so I can go ahead and write that our horizontal asymptote will be at 0. However, notice we actually have a constant being added, and so we can go ahead and write that as 0 plus 3, which means our horizontal asymptote will be at positive 3. We take a look at our vertical asymptote, and of course here we're going to set x minus 5, what we see in the denominator, equal to 0. And ask yourself, what would you do to get rid of a negative 5? Well, of course, we will add 5 to both sides. and this will give us x equals positive 5. So we have a vertical asymptote at 5. Now, at this point, kind of as always, we have enough information to begin to roughly sketch our function. And so we'll draw our xy axis. And let's go ahead and start always by graphing our horizontal and our vertical asymptote. So I see that my horizontal asymptote here is at positive 3. Let's see, our vertical asymptote is here at positive 5. Now in this case, it's going to be a little bit different because the next question we ask ourselves is, do we have a positive or negative function? And in this case, we'll notice this is the first time that we actually see a negative function with an x squared in the denominator. Well, remember, whenever you have a negative leading coefficient, all it does is take our function and reflect it over the x-axis. So in essence, instead of us being up here in this quadrant 1, we reflect down into essentially this quadrant 4 right here. Now remember, our other side of the graph, whenever we have an x squared, was also on the positive, kind of this quadrant 2, if you will, but once it reflects down, it will then look like this as well. And there you go. We've graphed our function. The last things, of course, we want to go ahead and write down our domain. We see that to the left, it extends all the way to negative infinity. And as we go towards the right, what is the value it's approaching but will never touch? And of course, in this case, that would be 5. And I hope you've made this connection by now, but the vertical asymptote will always be intrinsically connected with the domain. And so let's see. The one thing I missed here, we need to write this u for union, 5 to positive infinity, because we see it does not stop going to the right. Let's talk about the range. So as the domain is connected to the vertical asymptote, our range will be connected to our horizontal asymptote. We can say, hey, this thing, what is the highest value? Like, how high can it possibly go? And the highest it can go is all the way up to 3. And the question then becomes, how low can it go? Which would be negative infinity. Alright, I hope that these examples have helped you out. You have these 10 problems to do today, and I will see you guys on Wednesday on our level 3 and level 4 video. Alright, here we are in example 2, which says graph f of x equals 5 over x plus 1 squared minus 4. Now, once again, the very first question we ask, is this top heavy, balanced, or bottom heavy? And in this case, since all of our x's are on the bottom, we know it is once again going to be bottom heavy. So we can say, alright, our horizontal axis, or our horizontal asymptote, I should say, will of course start out as 0. However, notice we have a constant being subtracted out here. Remember, to all your transformations, whenever you add or subtract a constant, you shift your graph up or down. So we have to include this negative 4 right here, and it turns out 0 minus 4 will of course give us negative 4. And that will be our horizontal asymptote. Okay, let's take a look at our vertical asymptote. So with that one, we can still look at the denominator, and we'll set this x plus 1 equal to 0. And obviously, we're always looking for the x that makes the denominator equal to 0, because that's the one x that we just can't have. Remember, you can never divide a fraction by 0. So of course, to get rid of plus 1, we will subtract 1 from both sides, and it turns out x equals negative 1, which of course will be our vertical asymptote. Now at this point, we actually have enough information to go ahead and graph this function. So we'll draw our xy axis, and I encourage you to do this on scratch paper at home. Draw it with me, and let me go ahead and switch our asymptotes to a nice red. And it looks like our horizontal asymptote is at negative 4. So I go down 1, 2, 3, 4, and I draw that dotted horizontal line. Okay. It looks like our vertical asymptote is at negative 1, and so I'll draw that vertical dotted line through there. And at this point, we can actually go ahead and begin to graph the function. Now notice something. Is our function positive or negative? And in this case, since it's positive, once again, our very first section of the graph will kind of be in this top right quadrant. I know that kind of blended in with my xy axis, but hopefully you can see this fairly well enough. Okay, Now, the next part of this is you have to ask yourself, on the bottom, do we have an x or an x squared? And since we do ultimately have an x squared, remember, no matter what happens whenever you square something, it will always become a positive. And so that being said, that means that on the flip side of this, our second portion of the graph will also have to be positive, essentially here, meaning they will be above the horizontal asymptote. And at this point, we've successfully graphed our function. Now all that remains is to go ahead and write out our domain and our range. So as we look at this, we ask ourselves, how far to the left does this graph go? And it looks like it goes all the way to negative infinity. Now as we go to the right, what is the point at which it begins to stop or slow down? And of course that is at -1. Okay. Now our domain will be the union of the left portion of the graph, negative infinity to -1, union with -1. So we've gotten past the asymptote. We're starting on the other side as infinitely close to -1 as we want to be. And then we extend ourselves to the right, going all the way to infinity. Okay, let's take a look at the range. Now remember, the range here is quite a bit different when you just have x. Remember, when you have x squared, there's essentially nothing down here below the horizontal asymptote. And so we simply start at wherever the horizontal asymptote is. In this case, our horizontal asymptote was -4. So we'd say that our range goes from -4 all the way up to positive infinity. Once again, I encourage you to pause this video, finish taking the notes, backtrack if there was anything that was unclear to you, watch it one more time through, and let's go ahead and move on to our third example.